Question 6c. Hence or otherwise, find the value of theta for which the real part of z over z minus 2a is equal to 0. So when we see something like this, hence or otherwise, we most likely want to make use of information that we've found out in the previous parts of the question. So I've put some of that information out to the side here. So from 6b part 2, we know that the argument of z over z minus 2a was equal to 2 theta minus pi. And also from part 6a, as we know a and b were both positive, so therefore z is in the first quadrant, and hence theta must be greater than 0 but less than pi over 2. So we're going to use all that information to help us solve this question here. So we want to work out the value of theta for which the real part of z over z minus 2a is equal to 0. So the real part of a complex number, well, that's the cosine part when we write it out. So we want cos of our argument, which was 2 theta minus pi, equal to 0. So we don't know the modulus, and we don't actually need to know the modulus, because as long as cos of 2 theta minus pi equals 0, well then our real part of the complex number is going to equal 0. So we want to find, well, cos of what equals 0? So we know that cos of pi over 2 is equal to 0, but we can also have cos of 3 pi over 2 or negative pi over 2. Cos of all those numbers will equal 0. So therefore we want our argument, which was 2 theta minus pi. If we have that equal to, or either plus or minus pi over 2, but we could also have plus or minus 3 pi over 2. Any of these will give cos of 0, and so on. Plus or minus 5 pi over 2, 7 pi over 2, and so on. So as long as the numerator is odd, cos of any of those will give 0. So cos of 9 pi over 2, for example. Okay, so now we just need to pick, well, which one is it of these? So what we know about 2 theta minus pi, well, we know it's less than 0 and greater than negative pi. So how do we know that? Well, we can look at that in two ways. One, if we just come around on our Argand diagram, come around negative pi, well, we know that theta is less than 90 degrees, or less than pi over 2 radians. So adding 2 to that, 2 times something that's less than 90, we're not going to make it back to the real axis or into the first quadrant or anything. So we're going to be around here in these areas somewhere. Okay, another way to think about it is if you just start with the information we knew from 6a, so we know that theta was less than pi over 2 and greater than 0, as z was somewhere in the first quadrant. Well, then if we multiply everything in that inequality through by 2, well, then we just get 0, 2 theta, it's going to be less than pi, and then subtracting pi from everything, so that's going to imply negative pi, and then 2 theta minus pi, and it's going to be less than 0. Okay, so coming back to our problem, so 2 theta minus pi, which I just underlined in red there, is equal to one of these things here. So which one is it? Well, looking at our inequality, so we know it has to be between 0 and negative pi. So greater than negative pi, less than 0. So it can't be any of the positive numbers up there. It can't be positive pi over 2, positive 3 pi over 2, etc. The only one it actually works with is negative pi over 2. Okay, so not the positive, just negative pi over 2. Okay, and not any of the other ones. That won't satisfy that inequality. So now we can write out our equation. So we know that 2 theta minus pi is equal to negative pi over 2. And then just add pi to both sides to get 2 theta is equal to pi over 2. And therefore theta is equal to pi over 4. Okay, and that is question 6c.